anyway, while Steph's doing that, and we might end up just skipping the first slide, you can probably see down the bottom here where my hand is, or with my previously made arrow that I have created, there's a very basic type of similarity between all digital multimeters. Effectively, they're just a tool for measuring electrical characteristics. There we go. So I think there might have been a slide before that, but that doesn't matter. Essentially, all multimeters are the same. They have probes like these little guys over here. They have little metal tips which are used to touch onto points in a circuit or on a battery or whatever it is you're interested in measuring. There's a dial in the center of the multimeter, which is where you control which actual characteristic you're interested in measuring. And you have an LCD screen, which will actually display whatever it is that you're measuring at the time. You can spend hundreds, possibly thousands on multimeters, but you really don't need to do that if you are planning on just using it for basic diagnostic tests. Something in the order of about $15 to $50 will be more than enough. Almost all multimeters measure voltage, current, and resistance, but in terms of using them for diagnosing problems with camera traps, I really recommend getting one that also has continuity, and preferably one that has continuity with a buzzer. And I'll get to that in a little bit. I'll show you why that's important. So next slide, if that's okay, Steph. So look, I won't go through everything on the slide because obviously we've got 3 presenters tonight and a bit to get through. Come back and look at these details if you need to, but essentially I've mapped out there or annotated what a basic multimeter looks like. It's probably most important that you just get to know what these symbols mean on the dial. So for example, there's a V. It's pretty standard to have a V with a dash line and a solid line for DC voltage. Resistance is in ohms, and amperage is usually a big capital A or a little m and a large A, or the microamps is usually a separate thing. There's usually multiple ports for the probes. Some really cheap multimeters only have 2 probes with 2 ports, but generally you have a port that's for voltage and resistance, and then you have one for your amperage. So we'll just go to the next slide if that's okay. And I'll quickly go through. Can you hear me okay?
Yep.
If you just hit the next slide. Sorry. Right. So I'm going to jump straight. Actually, just go back. Was that was the 3rd slide, was it? Sorry, Steph. Right. Perfect. So basically, to set up your multimeter to do these measurements, and as I said, you're probably primarily going to be interested in voltage, current, and continuity. But just for completeness, I'll probably take you through a couple of the other ones. It's important, as I said, to note on the dial where each of those different measurements is. And what I'm going to do is I'm actually going to take you through a very simple circuit that I've set up. But first I'll show you the schematic or the circuit, and I'll run you through kind of the elements of the circuit, and then we'll actually do a physical live measurement of each of the things. So if you don't mind hitting the next. Yep, so most of the measurements are done with the red probe in the voltage and resistance port, and with the black probe in what's usually labeled as the COM port or the ground port. On my multimeter, which is the picture that's shown on the screen, voltage, DC voltage, is actually measured or is set at the number 1 there, which I've got on the little image. Resistance is set at number 2. The diode test is set at number 3, and later I'll show you current. But the most important thing I wanted to show you here was the circuit that I've got, which is very, very simple. Essentially, it's a battery, which you can see down the bottom. It's a breadboard, which is essentially just a way to connect a bunch of stuff without having to solder things. And it's an LED, and in this case, it's not a through-hole LED, which is probably the more common type of LED that people are familiar with. This is one that would be commonly found on a more modern PCB. I've set up this so that we can basically go through all of the characteristics live. And Steph, if you just hit the last slide, I've put this specifically so people can come back to it because current is probably the thing that people have the most trouble measuring. So we'll just jump now into my camera, if that's cool. Right, excellent. So as I said, I have my circuit set up. Okay, so as I said, I had a little drawing of this schematic just to prove that it actually works. I'm just going to plug in my power here, and you should see that little LED come on there. So basically what the circuit is this battery, and the power runs up through this rail, up to the LED and back down to the ground side of the battery. And so what I'll measure first is voltage, and this is very simple. You take the red probe and the black probe, and you put them on the corresponding terminals of the battery, which in this case has the red wire and the brown wire. And you should be able to read on my multimeter there a measurement of about 3 volts, which is about right for this particular battery, which is an Energizer CR123. It's normally rated to about 3.2 volts out of the packet, but I've been using it a bit for testing. So the next thing I said was resistance. So this requires you to change your dial. You're not changing your probes, but you're going to change your dial around to the ohm measurement. And you'll get a little thing up here that says 0L and M and the ohm symbol. And just for completeness, generally you're not going to, you probably won't spend a lot of time trying to measure resistance unless you're specifically looking for, you know, a fault that might, for example, have a dodgy wire that's semi-connected but not completely connected. So just for completeness here, I'm measuring just this through-hole resistor, and it's about 10 ohms. As I said, generally, if you're going to measure a component like a resistor, which I don't think you'll spend a lot of time doing, you actually have to normally take them out of the circuit that you're trying to measure. Otherwise, you can get some spurious results. But on my multimeter, there's actually a much more useful type of measurement called continuity, and you might be able to just see that there's a little buzzer symbol, which on mine means I have to press that buzzer. And what this means is I can then touch the probes together, and I will get a buzzer which will tell me that something is electrically connected. So for example, I can touch my positive side of my battery, and I can go all the way up my breadboard here, and I can hear that from the buzzer that it's connected. Now, if you can imagine that was a broken wire or a blown trace on a PCB, something that's essentially disconnected that circuit, you can go along with your probes and you can essentially try and find the place where it's broken. So that's what makes continuity pretty useful. And then just for good measure again, I'll show you how to measure a diode. In this case, we're going to use the LED as the diode, and LED is just a fancy kind of diode. What a diode test usually does is basically tell you that the diode is working. So I'm just going to show you here using the probes.
Basically,
I don't know whether you can see that. I'm hoping you can. But the other thing that it did was it was actually telling me what the voltage was while I was measuring that, which is another useful thing for a diode. Right, so I'm conscious that I'm going to run out of time. So let's quickly do a current measurement, which is usually the thing that people have the most trouble with. To do this, you actually, not only do you have to change the dial, but you actually have to change the probes. So I'm going to take this probe out of the voltage port, and I'm going to plug in a new one, and it actually has a pre-built-in little alligator clip, which is pretty useful for measuring current. Now, all the other measurements that we've done before, and you can see I'm getting a warning here that's telling me I'm not going to be able to measure what the dial is on, which in this case was the diode. Because I'm trying to measure current, I'm going to go around to the amperage and milliamperage measurement. All the other measurements I've shown you were essentially in parallel. We had a circuit that was connected, and essentially we just used the probes to tap into the line of the circuit to get our measurement. But in a current measurement, you actually have to insert the multimeter into the circuit. So you have to break the circuit and attach the multimeter as if it's part of the circuit. That's the only way to actually measure current. And current is an extremely useful characteristic to measure for things like camera traps. So for example, if you want to know how much power your camera trap is using with a given battery or power supply, you would be using current to tell you that. And as tricky as current can seem to be, it's actually quite simple if you think about it from that point of view of just cutting into the circuit. So I had my power line connected here, so that was running the LED. To insert my multimeter into the circuit, I'm just going to unplug the battery power, and I'm going to plug in my multimeter to that side. The ground of the battery is still connected. So to complete the circuit, to complete the multimeter being added, I've only really got one option, which is to add my black probe to the power line that runs to the LED. And you should see when I do that, that the LED lights up. But more importantly, on my screen, you'll actually get a measurement. And that's the measurement in milliamps of how much current the LED is using. And you can use that to basically tell you, for example, how long your battery life is going to last. So look, that's a very basic demonstration of how a multimeter works. And I'm going to hand over to Alistair, who's going to show you how to use a multimeter in the context of diagnosing some of the issues that you have with camera traps. So over to you, Al.
All right, thanks, Rob. Let's get the camera screen switched around now. Okay, thanks, Ellie. So I've got my own different type of multimeter here, very similar. It gives the digital readout of what we're measuring, and Rob's gone through the different measurements. We're using volts to measure the voltage of the batteries that are in the cameras. And just to show that that works, I've just got one here, one AA battery that should be about 1.3 volts. There we go, 1.3. And yeah, this is just quite a cheap $20 device, and it's very handy if you keep it with you when you go on your field trips. Other tools, a set of small screwdrivers are very handy. Check on what kind of screws your camera traps have. If you're going to have to pull them apart and you don't have the right tool, it's not very useful. But sometimes even your pocket knife has enough tools in it to do the job. So this is one of the Reconyx traps. I've got some of the older Reconyx models here, and they've been out in the field a lot, and they've seen a few mishaps. There's a bit of a crack in the screen there, but so this is where the flash is. It's a white flash model, and this is the camera lens, and the motion sensor PIR lens is here. And all of these older model Reconyx have got the same clamshell casing. The batteries go in the back here, and you turn them on with a switch. You see that the flash will go off just to show you that it's started, and it'll tell you that it's reading the card and so on. You actually only need half of the batteries in most models to run. As long as you can create that circuit that Rob was talking about, then you can get away with using fewer batteries. It won't last as long out in the field, but it will start. And just for demonstration, this is what I'm doing today. Now, this camera here is very similar, same design. It's another Reconyx, the HC500. It's got the infrared flash, so you won't be able to see it with our eyes. It's got the same camera lens and motion sensor PIR lens there. Same battery case, and turning it on, I'm not getting anything showing up on the screen. So the first thing I check is just whether the batteries, do we have batteries in there? And we can check the voltage that the batteries have. So 1 voltage, I know that these are freshly charged. They have 1.35 volts, so that should be fine. But looking a bit closer, one of my batteries is upside down. Turning it on, this is a very common thing that I do. After you've put 1,000 batteries into a camera trap, you're going to get one upside down. So check your batteries, that's a common fault. And this is another model of Reconyx. This is the PC800, again with the infrared flash, the camera lens, and the motion sensor. This one had a run-in with some cattle, so the cows had opened it up with their mouth and then knocked the whole post over onto the ground. So it was then left in the mud and the rain, and you can see a lot of that mess has ended up inside the battery case here and all over the camera. So it's a good thing to do at that stage is to get in there and clean out all the mud, clean out the sand. A good way to clean electrical things is with isopropyl alcohol. Ethanol will work fine. And at a pinch, you could use some WD-40 just in a really small amount. So spray it onto your cotton tips away from the cameras, and then just rub the contacts clean, because you want the metal pieces to be really nice and shiny to translate all that electricity through. So after doing that, it still wasn't working. We can check each of the battery voltages one by one, or we can check all 6 in a row. Let's get that back on the screen. So 6 times 1.35 will give us the answer of 8.1 volts, you can see on the multimeter. So I know that all the batteries are in there working, and they're making a circuit within the battery box. So the battery box is fine for now. Tracking it down, the power goes through this white cable and inside the camera case itself. So there's 4 screws that undo on these old Reconyx cameras, and I've already done a couple of them. I'll just flip these open quickly. Okay, and inside the camera, we have the LED flash, we have the camera lens, and this is the PIR motion sensor. So from the batteries, we see that white cable come inside the camera case, and it meets up on the circuit board here. And we can test whether that power is getting from the batteries onto the circuit board on these test pins down here. And we can see that we're getting 8 volts off the circuit board. So we know that the cable and the connector are okay. Sometimes that will come loose, particularly like in our case where the cow was chewing on the camera trap. So you might have to dig further and find out where the electricity is getting to. On this model, we had a few because they'd been submerged in mud and sand, where the switch itself was having a problem. So there's some dirt and sand gets inside the switch. Normally it's just perfectly weather sealed, but because it had been left open in mud, we found that that was an issue. So this is the back of the switch here, and you can actually short these pins. You can test it with the multimeter, but you can short these pins with a piece of metal. And to know when the camera turns on, you'll see this LED turn on here. Okay, so just doing that, we've worked out that the switch is the faulty problem here. So we can further pull the camera apart, take off the LEDs gently because they've got some long metal pins on them you need to keep straight. These pins all have to line up back in their spots when it goes back together. And there's 5 screws that hold this board in. I've only got 1 in there at the moment to make it quick. Okay, and turning this back over, this is the switch, and that's what we've just worked out where the problem is. Now, you could desolder the switch or take it to an electronics person who could remove that and put a new one in there for you. But I found out you can actually just take this little plastic cover off, carefully prying it off with a little flat screwdriver. All the switch is this sliding little toggle here, pressing on this little metal seesaw on the inside. If you remove the little metal seesaw, you can then clean out the inside. Again, getting one of your cotton tips, clean out the gunk on the inside. Might need some more scrubbing. Okay. Put that little metal seesaw back in. Oh, and we can see a flash on the screen there. Come on. And I'll just put the top of this switch back on. And by cleaning out that switch, we've now managed to get this screen to come back on, and we've got power going through the system again. So this is just one problem that we had with these cameras. Usually they're quite good. It's just when the cattle have knocked them over and they're exposed to the mud that it's, yeah, it can cause some problems. So yeah, load up some questions in the chat, and we'll see if we can got any answers to some of the problems. Otherwise, we'll probably start up a thread on the WILDLABS website on the forums, and yeah, we'll see what problems people come up with and if anyone's got some fixes for them. So I guess it's now on to Laura, and to tell us about some of the other options where you can take your gear to get them repaired.
Hi, yeah, thanks. I'll just share my slides with everyone. There we are. So yeah, there are a couple of things that I wanted to touch on before we finish. I don't know if I hope you can see the slides. Rob and Alistair mentioned screwdrivers and multimeters, which shouldn't be too hard to find, but should you need more tools and supports, then I want to mention places that you can find some, as well as some ideas inspired by the repair movement, which tries to raise awareness about the consumption of electronics and coordinate with lawmakers and manufacturers to try and improve the design and recycling of these. And so, yeah, a couple ideas inspired from this movement that we could take on, for camera trappers and tech for wildlife community, and to make it easier for others in the field. So some of the resources you may be very familiar with, but you might not have thought about them in this context. So I'll just quickly run through them. In terms of finding tools that you don't want to invest in or are not sure where to find, a good place to find these and further support and expertise could be makerspaces. A lot of you will know this already, but they're places that make tools and materials available for people to learn and experiment with them and build, but nothing says that they can't be used for repairs as well. And as you can see on this map here, they've got a really wide geographical spread now. So there might be one close to where you are in work, especially if you're in a university. My own university, University of Sheffield, has one that's accessible to staff and students, and I've popped a little picture here. Then there's other places that have different names but similar functions, making equipment available and functioning as hub of expertise. And these are things like hackerspaces, fab labs, tool libraries, and repair cafes. And repair cafes bring me to my next point, actually, which is that if you feel inspired by this tutorial and have a lot of camera tech to fix, you could organize an event bringing together people with the know-how and the expertise, and people have got a stock of faulty cameras to fix. And that's inspired by the repair movement again, and the sort of the cafes and parties that they organize, mostly with volunteers. The Restart project, which is one of the NGOs working in this space, actually has a really useful step-by-step toolkit to organize one of those events, and I'll pop a link in the chat in a minute to this toolkit. But it could work really well, especially if you're working as part of a conservation hub with a lot of different colleagues and organizations, or if you regularly collaborate with electronics engineers. Obviously, it's not the easiest thing to do at the moment. Although a lot of these events have moved online, it's harder to share equipment. But one thing that you could do now, and that's perfectly compatible with public health measures, is collecting and sharing data about the repairs that you do or attempt to do. And that's something that the Open Repair Alliance does. They get their local networks to collect information about the phones and computers and smaller appliances that they repair, and kind of use that to communicate with manufacturers and lawmakers about improving design and detecting patterns of recurring faults. So one thing that would be really useful to share, I think, would be the model, the brand, the issues that you found, how you've gone about fixing them, and whether you were successful or not, because not every fault is going to be fixable or easily fixable. And so we've created a spreadsheet for this that's going to be on WILDLABS, and we're going to put a link in the chat as well. So yeah, if you could share this information, that would be really good to both help other diagnose faulty devices, maybe give them an idea of where to start with repairs, but also help people make decisions about buying new cameras, because if there's some make and models that consistently run in similar issues, then there's no point investing in them in the first place. And maybe longer term, highlighting patterns and recurring issues could be a thing to take up with manufacturers, and that could be used to inform the design of future models, although that's yeah, a few steps ahead. But yeah, I hope this has given you some ideas of steps to take, and I'm excited for the Q&A and to hear what you think.
All right. Thank you, all three of our presenters. That was great. We loved the new camera angles as well. That's our first time having one of those fancy flat angles. So we are about to start the Q&A. I will drop the doc link one more time in here. You can ask them anytime during the Q&A. We've got them in order, so if you have another one, just drop it in there after number 6. And if everybody wants to turn on their cameras, all of our presenters, and you guys can as well for the Q&A. There we go.
Hey, Laura, do you want to just stop sharing your screen?
Oops, sorry about that. Yes, I do want that.
There we go. Okay. So I will go ahead and get started with the Q&A. So first we have one from Carlos, who does not have a mic, so I'll go ahead and ask for him. He would like to ask all three of you, what are the major camera trap failures that you've encountered?
I'll start on this one. I've seen probably animal damage to cameras a lot of the time. It's curiosity, whether it's the dingoes in Australia or the dogs that are here, and they'll just come and sniff and smell people's handprints on the cameras and chew on the plastic, and cattle and things. So it's that physical damage that we see a bit. Even birds pecking at the screens and the lenses. There's some of the things. So it's some of the ways of avoiding that is where you place your camera. For one deployment, we used a metal mesh just around the sides of the camera just to give it a little bit of extra protection. Yeah, Rob, have you got any other ones that frequently have issues?
Yeah. I mean, I noticed, Thomas Lab, you mentioned little acorns. That's a camera I've used a lot of because they're quite cheap but quite pretty good quality. Biggest things I found with them, and probably with virtually any camera, I reckon, is it always start with either the SD card or the batteries themselves. A really good workaround, and you'll see this recommended by quite a few camera trap people, is to avoid using the actual inbuilt AA battery packs altogether, because over time you can get all sorts of problems. Alistair had a camera that the whole side split apart, so the batteries weren't actually in series anymore. To do that, basically what you're going to use is something like a 6-volt SLA battery, and you're going to plug it into the DC jack. Most cameras have a DC jack that you can put a power supply into. That's certainly the reason we started doing it was because most commonly we needed cameras to run for months and months at a time because we weren't going to be going back to them. But it also can help alleviate quite a few problems. So it's worth having a crack at that if you're having issues. I noticed another bunch of comments about things like water and condensation that get into the camera, which can be a big problem. One thing to start with, I reckon, pretty much the most sensitive parts of your camera, or the parts of your camera that you don't really want to mess around too much with, are your lens itself and the PIR, and obviously your LEDs, your infrared LEDs. But virtually everything else is free game in a sense. So I sometimes, with stuff that I know is going to be in an area where it's going to rain a lot, I will just open it up and just spray the entire thing with silicone spray. Silicone sprays you can get from virtually any electronics or car maintenance stores. They do vary in quality, and I'm happy to recommend some, but generally if you just look for a silicone spray, I think that's a good start. The other thing is, like, you can spray that into switches and into little ports. I wouldn't go nuts spraying it like into your SD card or your jack or anything like that. It's not conductive, but if you use too much, you can end up, if you can imagine, like, dust and stuff like that will actually stick to that because it's quite sticky. So you don't want to have too much there that stuff's going to get stuck to. So I would say that from my point of view, from my experience, always start with batteries, then look at your SD cards. There's lots of weird little idiosyncratic things with different models. They usually require very specific kinds of formatting. Some of them don't allow card sizes above 8 gig. Some don't allow anything above 16. So take a good look at your manual if you start having problems. And then, obviously the point that we've tried to make is, as you start doing this, because this is really going to be a collaborative thing, we're hoping, start telling us about what you've tried, what faults have you detected, and start logging that with us. And look, hopefully amongst all of us, we might be able to get a bunch of camera traps that for any other reason are just sitting in a basement somewhere back out in the field working again.
Okay, brilliant. Either of our other presenters have anything to add? Al, Laura?
I'm happy just for more questions, to be honest, Ellie, if you want. If people have any specific things, if we can help.
So we've got some more in the doc, and it looks like we also have a couple of questions that just came up during your answer just now. So we've got one from Adrian and also from Carly. Do you both have mics if you want to ask those right now while we're still on the subject?
Hi.
Hi, Carly.
Hello.
I just had a quick follow-up. So it's safe to spray that like silicone spray directly like onto batteries? Because I never sprayed it like inside because I didn't want to mess anything up, but like I know nothing about electronics.
Yeah, no, it's pretty safe. I wouldn't, as I said, I wouldn't go nuts with it, but you can definitely give a little spray coating over your battery terminals or whatever. Just be careful of things like dust as well. If it's going to be in a really dusty environment, silicon can actually, because it's sticky, like I said, it can actually make things worse sometimes. So just be conscious of that. But yeah, generally you can definitely spray it. It's not conductive, and if you don't trust it or believe it, you can test it again with your multimeter. You can just spray some on a surface and touch your probes together using that continuity thing, and if it was conductive, like say water was, it'll actually join, or it'll tell you what the resistance is. But silicon spray shouldn't register anything, hopefully.
Okay, yeah, I am in a tropical rainforest, so dust is not really the water. Humidity is the larger issue.
Yeah, I saw that as well, and someone else suggested this. Those little silica gel packets that you can get sometimes in like medicines and tablet things, you can actually get them pretty easily yourself, and you can just put like 3 or 4 inside your camera. That can actually help solve some of those issues. If you get really big problems, one thing you could try, I'll probably start with maybe a camera that you're not as concerned about. Alistair kind of stepped you through the process of sort of opening up a camera and going in, and basically what you're trying to get access to is your camera lens here, because this is essentially where the condensation is most likely causing some troubles, I imagine. And you could try spraying a little bit of alcohol around that sensor. Try not to get any on the lens if you can avoid it, but just anything basically around it. And that's another. And you could even, if there was some room, if you could work out there was some room, you could put try and get a little silica gel packet and put it inside. Try avoid touching anything too overly sensitive like the PIR. I think, again, Alistair pointed out, that's down, it's usually down the bottom here, and it lines up with this little Fresnel lens here, and it'll look like a little metal round tube. Don't mess around too much with that if you can avoid it. But yeah, it's certainly worth a try.
Okay,
Did that
great.
sort of help?
Carly?
I bored her so much that she's fallen asleep.
No, sorry, I'm here.
There she is.
I had undone it because I was gonna let other people.
Sure, Carly.
You
sure.
have not bored me. Trust it. No.
Okay.
You wouldn't be the first person that I've sent to sleep with my long chats that I.
Okay.
Okay, so next up, we've got Gabby, who I think has a mic. Gabby, are you there?
Hi, can you hear me?
Yes, we can. Go ahead and ask your question.
Well, so I have a few issues with my camera traps that I've been posting on the chat, and people have been also answering me. And it's the same problem that the previous girl I asked, with moisture in camera lenses and inside the equipment. And so what I gather here is that I should probably use the spray of silicone, that kind of products, and perhaps if I can get them, silicone gel packets. Yeah. But I didn't. I'm really unsure about the condensation on the lens, because there is no way to get there, and perhaps I didn't catch what you recommended to avoid condensation on the lens of the camera.
Yeah, I'll quickly say again, it's obviously once you start going inside this little box here, which is where all the electronics are, things can get potentially a bit messy.
I would not like to go inside.
Well, Well, I don't necessarily think it's a bad thing. There's nothing in there, particularly if you don't have any batteries connected or any power connected. You're not really going to be able to do a lot of damage unless you start literally just hacking at it with a screwdriver. But one thing worth trying, I think, and I would start with maybe 1 or 2 cameras just as a test. But Alistair showed before that isopropyl alcohol. Just a tiny little bit of that around the lens. Don't actually touch it on the camera itself, on the camera lens, but just a bit around it might also help stop it from getting a lot of condensation. Unfortunately, the camera lens, the camera itself is a little self-contained unit. And so if condensation actually gets inside that, probably the best thing to do is to try and get that lens into something like rice. So take the assembly off and then sit the PCB in a kind of a bag of rice, and then hopefully that will suck the moisture out of the lens. Ultimately, though, what you might end up having to do is replace the lens yourself, but it might end up being too expensive or too difficult to do that. But I think silicone spray is a good start. You could try also angling the camera slightly differently so that if you are getting, I mean, basically what condensation is air inside the assembly that has water in it. And that can be pretty hard to deal with because essentially that's not something that you did. And you send it into these environments where that becomes condensation. But things like silica gel, those little silica gel packets, stuff like that, at least should give you a fighting chance, I think.
Sorry, so just to be clear, the spray of isopropyl alcohol inside the electric part is not a problem for the equipment?
No.
Okay.
No, in fact, it's a really good way of cleaning PCBs. If you get like rust or corrosion on metal parts, you can actually use isopropyl alcohol. Again, it's not conductive. It seems counterintuitive because you're putting a liquid on a piece of electronics, but it's not conductive like water, so it should be safe. Yeah.
Okay, perfect. Thank you so much. And
please let us know how it goes. Like if you try it, please come back and tell us how it goes.
Okay, yeah, sure. I can send pictures before after. But something else, the silicone spray, it should be done, you said, on the batteries, directly on the batteries, and also like in the place, I don't know, in the joint of the camera, you know, like
in that joint.
Yeah, in that.
Basically, I'd avoid the front.
Yeah.
Because you're going to obviously obscure your lens, but you could certainly, I think, if you covered it, you could just spray it around the whole thing like that. I've also seen people, I think somebody mentioned before, Vaseline.
Yeah, it was
Vaseline. Yeah, okay. So Vaseline I would use if you're getting ants, because they won't want to cross the Vaseline. But you need to be a bit careful. There's probably better stuff than Vaseline. Like you can get some pretty hardcore engine greases that are much kind of, it's going to sound silly, but drier to the touch. And they're good because they're not like Vaseline in that they melt and then spread. They just tend to sit where you put them. So it'd be worth going into a car maintenance place if you have one nearby, or speaking to a mechanic if you have one, and just saying what kind of grease would you use, because they use high temperature greases, and that stuff tends not to melt.
Yeah, that's great. And I have a few more questions, but I don't know if you want to move on.
No, go.
Okay, so I have these rubbers that have expanded and also detached from the camera because I use Vaseline. And what should I do? Should I cut, you know, the part that got expanded and try to adhere the gums again to the camera, or
so
should I do?
So Do you mean that kind of gasket that runs around?
Yeah, it expanded and it's like bigger. And when I close the camera, I mean, there's no problem. But when I open the camera, it's just away. So.
Yeah, I mean, gaskets are pretty problematic thing sometimes. You can actually, again, from a car maintenance place or a car repair place, you can actually buy a gasket maker, and you can either make a gasket yourself, but that's actually quite tough to do. What I recommend is you can buy this gasket maker that has actually in a tube, and basically you just put some on your finger and you run it around, like take the old gasket out.
Okay.
Run it around. It's kind of like a paste, and it goes around, and you can clean it up, and it'll basically fill in, because basically all the gasket is when you press it together, it pushes and creates pressure so that water can't get past it. So you're just effectively trying to replicate that.
Oh,
It won't be quite as good, but you can definitely and then if you wanted to, I probably would let it set, and you want to try and, I don't know whether you can see, but see how this one is quite flat?
Yeah.
Like it's not sticking out too much.
Yeah.
So you want to make sure that you wipe, if you use that gasket maker, make sure you wipe it so it's nice and flat. And so when you put the thing together, it's not too much pushing it apart, because otherwise then you can get problems.
Okay, so the recommendation would be to get it out and to put it a new one, like with that.
Yeah, make your own basically. Yeah.
Yeah, could you write it, because I don't know, I don't know that product. So maybe look.
Okay, guys, why don't we connect you guys after the call?
Cool.
Yeah, sorry.
Just
Yeah, so we have a thread where you can post all of your follow-up questions, and you can find that in the collaborative doc. So we do have to move on. I'm so sorry, but I'm really glad that you guys are having a good conversation. That's what these are for. So please follow up with each other afterwards, post it in our forums. Juan, you are still here, and you said you have a mic. So go ahead whenever you're ready.
Yeah, no, well, first of all, thanks, guys. This was really great. I'm really excited to get going with some camera traps that have been sitting for a while on a shelf. My question is pretty simple. Will you show like a basic repair with some of the Reconics? And I was just wondering like how similar the circuits are across brands. We use the Bushnell's, Reconics, and Brownings in the field. I was just wondering like how similar they are, and if they're equally simple to diagnose or repair. And also, like, can you just tell where things are going just from looking at the camera itself, or do you need access to the diagrams for the camera?
I haven't worked with a lot of brands myself, but yeah, a couple of Bushnell models and Reconics models, and they're fairly similar in that, like Rob was showing, like from the outside you can see where the camera lens is, you can see where the PIR is and the flash is, and they all line up on the inside. Your battery compartments might have different numbers of batteries, and you just have to follow where that cable goes to see whether it's a battery problem or it's in the camera problem. But yeah, once you get inside, trying to follow the traces of the electronics and that sort of thing can be pretty challenging. But there's probably, once you start getting into the small pieces within the camera, it might be a big step to go beyond checking the switch or some of the big components if they're obviously broken. I'm probably not familiar enough with the electronics and the chips and that sort of thing to know where to go beyond there. Rob, have you pulled too many of these different things apart?
Yeah, I think once you start getting into, actual component failure, like say, for example, your LCD screen just gets cracked or broken or something like that. One, it's probably inevitably going to be cheaper to buy a new camera if it's a cheap camera. However, one of the goals, I guess, of this forum is to try and establish something like a swap meet too, where people might say, well, I've got a camera that's got a busted PIR, but it's got a perfectly good lens, and you might say, well, I've got the opposite, why don't we swap?
Right.
And I think that could be one way to try and solve problems. I don't think. Look, there's a lot going on in a camera trap that is beyond basic repair. So, for example, if chips fail or ICs fail, it's almost not worth the trouble trying to replace them. Like, for example, there's firmware or software that's essentially running on those chips. So just replacing the chip might not actually fix the problem. However, if you had spare cameras, like I said, and you had lots of different faults or breaks, you might be able to take 3 cameras and turn it into one working one if you can find out what the problem is. But generally, I think if you're just starting out, start with basic problems like maybe your SD card isn't working properly or the batteries aren't working properly, and start going through the motions of I guess starting with the simplest stuff and then progressively working through. And look, who knows, in 2 years' time, if this forum kicks off, maybe we'll all be, desoldering chips off boards and resoldering them on using, wave soldering methods and stuff, and, we'll all be experts at it. But at this stage, yeah, I mean, there are some general faults. I actually think, Alistair, the reason Alistair showing the switch issue is a good one is because switches on cameras are notoriously bad. So the Bushnells, for example, I think you mentioned Bushnell. This is a Bushnell here. The switches on these things are awful.
Yeah.
And so getting familiar with how the switches work and maybe how to fix them, and even some workarounds, like, for example, you could make your own switch. A switch is basically just a thing that's a metal contacts that are separate, and then you push it together and they complete the circuit. That's all a switch is. I mean, essentially you could use 2 wires to do that. Mm-hmm. These switches are 2-stage switches. So they usually have the setup and then the power on stage. So that's a little bit more complicated, but essentially that's just 2 pairs of wires. So I'm hoping that we get people kind of, coming up with some really interesting solutions. But I really encourage people, particularly if the cameras are just sitting there, just start taking a look at them. I mean, I found one the other day. This Bushnell was not working. It wouldn't activate. So I could wave my hand in front of the PIR and it wouldn't activate. And I opened it up, and inside I found this little piece of foam. I don't know whether you can see that.
Yeah.
Inside the PIR Fresnel. So it was covering the lens of the PIR. So nothing could detect it. Now, I don't know why that was there, but that was the solution to that problem, was take the piece of foam out, and the camera works perfectly now. So look, it's worth kind of starting simply and going, right, start with batteries. Batteries aren't working. The other thing that I do a lot, and I think it helps a lot, even just for morale building, is go online and have a look. Some people have forums where they're like, I bought 10 Bushnells and I had this problem and I sent it back to them and they told me this. And so you can learn quite a bit by doing a bit of that sort of research. But I don't know whether that helped at all. But.
Yeah, no, that's great. Thanks.
All right, great. So we are at the hour. We have a few more questions left. If you guys are happy to keep going, I'm sure everybody that's been here for previous episodes knows that we run over quite a lot. So if our presenters are happy to stick around, we can finish up these last few questions. How do you guys feel about that? Okay, great.
Sure.
So our next one is from Jamie, who does not have a mic. So I'll go ahead and read that one out. What is the best way to diagnose and fix issues with the detector? I have many cameras after scraps by animals where the camera just takes photos repeatedly. How can you tell if this is the trigger damaged and repeatedly firing, or the detector believing something is ever present in front of the camera?
Right. That sounds like a difficult one to think about. Some of the things you can test just in the software itself. So some cameras you can tell it not to take a photo based on motion, you might be able to set it to time lapse only. And if it's still taking repeated photos when you're only in time lapse mode, then it's not going to be an issue with the sensor. That's one of the options you can use to test things. Just try the different software options for how it takes photos. Then once you've found out if it is something to do with the motion sensor just continually triggering, have a look at the lens itself, the Fresnel lens here. There'll be different shapes and different orientations of how they work. If that's been damaged, then there's potential for that to be throwing off where the heat signature is coming from. Also, if it's been damaged, like if it's been punctured or if water's got into the camera, the actual PIR sensor behind it, which Rob was saying, don't touch it. It's this little silver can in the middle just above my finger. It's a tiny little component, and that's what measures the change in temperature moving in front of the camera. If that gets damaged, then yeah, they're a very difficult thing to be able to pull off the board and replace with something. One issue is actually being able to find the same part number to replace it with. But if the camera is broken and it's not fixable by anyone else, maybe you've got the chance to actually fix one and show everyone else how to get it done. Work out what the part number is that you need to replace it with, and yeah, put it into the document as to this camera needs this part and this is how you fix it.
Okay, awesome. We have two more, so we'll try to barrel through these in case people are logging out. So our next one is also from somebody who does not have a mic, Santosh, who says, anyone using or fixed Panthera V4, V6 camera traps here? Yeah, we have a lot of cameras with timer and flash issues. Is there any material to fix them ourselves? That would be great.
I haven't heard of that model. So I'm probably not going to be very much help with that specific model. Just very quickly, going back to that PIR thing, you can actually replace those little, the PIRs themselves. They're actually not that uncommon. If the model is relatively old, it can be a little difficult. I've actually replaced the entire motion sensor in a camera trap with my own motion sensors. So I've attached long wires that run to motion sensors like 2 or 3 meters away on either side of the camera. And we found that that's one way to deal with, for example, trigger time not being very good. Some camera traps that are cheap have very poor trigger time. So I actually have a bit of a step through on how to do that. We did that to activate GoPro cameras from just a standard camera trap. So I'm happy to share that with people. In terms of the Panthera one, I would start again with the simple things. It sounds like most people have very similar problems, right? So the camera's taking too many images, it's too sensitive. Obviously, as Alistair said, start with your software. And if you have multiple of the same camera, one good thing to do is to set them all up in a place where, for example, you have a high, say your setting is high, low, and high, medium, and low in terms of sensitivity, and then actually walk past them and see what the difference is. For example, you know, like your high one should be triggering much sooner or allow the photo to be taken much sooner. If that's not happening, you know, chances are if it's a cheaper trap, it's probably because the PIR hasn't been particularly well calibrated. So that, look, like, as I said, there are going to be some high level issues, firmware issues, you know, IC chips that aren't going to be easily replaceable, but it's just a matter of experimenting. And a lot of the time, if you put the work in, like I said, set multiple cameras up and then, you know, physically go and trigger them and then go and have a look at the results, you can actually start to pin down, is it the whole Panthera line? Is it just 1 or 2 cameras? All that sort of stuff, and just document it so that you and other people can learn from that. Sorry that that's not much help, but.
Okay, and we have one last question from Adrian, who I believe has a mic. Adrian, are you still here?
Yes, I am here. Hello, everybody.
There we go.
Okay, as I mentioned, we have an issue with a camera, Bushnell Trophy Cam Aggressor. It was given ridiculous resets of time and date, so we decided by mistake to reinstall the firmware. But what happened then is that the camera did not turn on. The red sensor is blinking like it's detecting, but the screen is off and nothing happens. Bushnell tells me to send the camera back to USA, but sending a camera from Argentina back and forth and the repair cost is more than the value of the camera itself. So I wonder if anybody has a workaround for this stupid issue.
Yeah, that's an interesting one. So you put did you put new firmware on the SD card and load it, and it actually loaded? Have you tried putting the old firmware on a SD card and repeating it, if that's how you did it?
We try to update the firmware with a firmware that is downloaded from the Bushnell Trophy page.
Yeah.
But apparently, or surely, this firmware was not exactly for this camera model. And what happened is that the camera do not start the screen for setup, and nothing happens. Only the red sensor is blinking.
So with that firmware, because I think I know like each of the Aggressor models, I think has 2 or 3 firmware updates that you can load onto the SD card. Are you able to go back to, because I think Bushnell actually has a huge list of all their firmware options. Are you able to go back and find the older firmware or the firmware that is correct? You can't find it?
Yes, no, because Bushnell only publishes the updates, not the firmware history. So you can't roll back if you want. At least legally. No, I don't know if there is some place where you can find the old firmwares.
Well, you should. So any camera, say the camera's like from 2015, there should be, because I think it goes by model number. I don't know whether you have the same camera. So I think it's model number and firmware issue. If you have a camera that has the right firmware issue on it, you should be able to go to the Bushnell site and find the right date and model for that update. Sorry, the right update for that model and for that firmware. I'm not saying it's going to work, by the way, but that's probably what I would start with. If you want to send me a direct line, Ellie can probably link us and I can have a crack, because I actually have a couple of Bushnells that I probably need to do something similar with, so I'm happy to have a crack at it.
Okay, thank you. I will do that.
No worries.
All right, brilliant. And that is pretty much all we had. We did have one more question from Shah, who asked what other resources there are for repairing camera traps outside of conservation. I believe he has logged off, so he cannot hear you insulting him.
Lord, what a diva.
Laura, are you still there?
Yeah, I am.
Hi. So I know you kind of answered this in the chat, but do you have any last second resources you want to give people, or tell them where they can get started for looking for those sorts of things?
Yeah, definitely look at, so Shah's suggestion of looking at what there is on hunting forums and hunting communities is probably a good shout, actually. Although I've not done that yet. We've got a broader electronics repair community and a lot of tutorial step-by-step repair sheets from this as well. And it's all in the collaborative documents, which I think is going to go with the episode video. So there we are.
You dropped out a little bit there.
A little bit. So everybody can find all of the resources from Laura in our collaborative doc, which I'll drop into the chat one more time. And that is it from us. I think that's all of the questions. Again, if you have any follow-up questions, you can go to that thread that is in the doc. You can leave our questions on the forums. We will get them to all of our presenters. You can ask each other as well. And also as a note, we have a little spreadsheet in there that we've created where you can list all of the problems you've had with camera traps. You can ask to do swaps and things like that with people. It's a really good way to collect all of that information and help the community solve these problems together. So thank you everyone for attending this a little bit chaotic episode of Tech Tutors, and thank you for sticking around with us. You can register for our next episode with Nigel Butcher, who will be talking about building bespoke conservation technology. That is next week at this same time, and I will drop a link to that in the chat right now as well. There it is. All right, thanks everybody. See you next week.